We're going to look at hyperbolas, which are different than a hyperbole, which is in English, where you're exaggerating a point. A hyperbola is a shape. So a hyperbola is the set of all points in a plane. The differences of whose distances from two fixed points, called foci, is constant. So if we look at this picture here, this is the shape that creates the hyperbola. Okay. So here's a focus and here's a focus. So it's kind of like two parabolas. Okay. So if you take the difference of these two from the point on the hyperbola to the different foci, that difference is the same. So we create this very similar to how we do our ellipses. So notice on our ellipses, our equation for ellipses was that we had, almost there we go, that we had something squared divided by something, something squared divided by something equals 1. And we were adding the two of them together, which was different than our circles where we had something x something squared, y something squared, added them together and it equaled r squared. So it wasn't being divided by anything. Okay. For our hyperbola, if we look at our equation, instead of adding, we're subtracting. Okay. So it's that same kind of setup as an ellipse, except for instead of adding, we're subtracting. Again, we have two forms here. You could have, so your hyperbola is oriented so the parabolas are opening, the parabola-like shapes are opening sideways, or you could have where they're opening up and down, right? So wherever the parabolas are opening towards the x, whichever axis it's opening towards, so these blue ones are opening towards the x-axis, that means that the x is first or positive and the y is negative. If the y is positive, then it's opening up and down. And if the x is negative, then it's opening up and down. Okay. You find your center the same way, but on this one, instead of creating, you find your vertex and your co-vertices the same way that you do on an ellipse. So the only difference between an ellipse and a hyperbola is how you draw it. Okay. So here, these 4 points would become your ellipse, and instead we make this little box here, and then we create asymptotes that go through the corners of the box through the center, and then those create asymptotes, and then this vertex is a point on your hyperbola, and then it follows your asymptotes. Okay, same kind of thing here. Here's your vertex. You've got your co-vertices, you make this box, you put your asymptotes through it, through the corners of the box and the center, corners of the box and center. And then you have your vertex, and then you pull towards your asymptotes, vertex and pull towards your asymptotes. Okay. We find the C value in the very same way, or not in the same way, close to the same way. So this is where it looks like our Pythagorean theorem. Okay. So before, our foci and our ellipse were on the inside of the box or the inside of the ellipse. Here the focus or the foci are on the outside of the box. So notice this is a squared plus b squared. So the hyperbola is adding in between for the c, squared equals a squared plus b squared, but subtracting on your formulas. And on the ellipse, it's adding on the formula or the equation. And then to find c squared, you're subtracting the a squared and b squared. Okay. So let's take a look at our examples. Okay. So this gives you a detailed information as to what I'm going to go over. Actually, it gives you a couple extra pieces of information. So here, our center is located at 0, 0. That's because there's nothing in here and there's nothing in here. So we're just located at 0, 0. Now here, since the x squared is positive, whatever's positive is what shows which direction it's going to be opening towards that axis. So since the x is positive, it's going to be opening like this. Now, just so you are aware, I could write this equation as negative y squared over 36 plus x squared over 16. So it's not always the thing that's first. It's really based off of what's positive or what's negative. Okay, so pay attention to that detail. So we're starting at 0, 0. we find the same thing to get our vertices and our co-vertices. So this is a squared, or this one's a squared because it's bigger, and this one's b squared. So we have, I guess in this case, they don't actually care about a squared and b squared. Yes, they don't care about a squared and b squared on this one. It just makes a difference on the ellipse one. So we have a squared is 16 and b squared is 36. So that means a is 4 and b is 6. So here, I know that this one, the 16, goes with x because it's below the x. So I'm going left and right by 4. So 1, 2, 3, 4. 1, 2, 3, 4. And then our b squared is under the y, so it goes up and down by 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to create a box with dotted lines. And then I'm going to create asymptotes that go through the corners of that box. I should have dotted that. And through the center. Now, it is important, so it's not based off of which direction it opens as to which one is taller or which one is wider, right? So on our ellipse, this one would be taller, right? But that's not based on where it opens. So whichever one is positive is where it opens. So since the x squared is positive, our hyperbolas open towards the x-axis. So these are our vertices, and these ones are our co-vertices. So I'm just going to start here, and then I pull towards the asymptotes, And that gives you your hyperbola. Now we also can find the foci. So our foci are from the center, and then we add our c value. So we first have to find the c value. Well, for hyperbolas, the equation is a minus. So inside the c squared, it's a squared and b squared added. So these signs are opposite of each other. So then we're just going to do 16 plus 36 equals c squared. So if we do 16 plus 36, that gives us 52. Equals c squared, so c is the square root of 52, which is 2 and 26, and 2 and 13, so that gives us 2 root 13. Okay. So if we go to put 2 root 13 in the calculator, that gives us 7.2. Okay, so we know this distance is about 7.2, so we've gone over by 4. 5, 6, 7.2, 5, 6, 7.2, and then those are the foci. And usually they subscript them as 1 and 2. Okay. Now, we want to find those exact values. So we go from our center, and we go from our center to the left, and from our center to the right. So we're changing our x value of the center. So since our center is 0, 0, that means that our foci is going to be positive or negative 2 root 13, sorry, and then keep the y value. So we did 0 plus or minus 2 root 13, but in this case, since we're just at 0, then it's really simple to do the addition. Okay. Now, if we look at this one, we're subtracting, but nothing's being divided and it's not equal to 1. So what I'm going to do in order to set it equal to 1 is I'm going to divide by 64 on each one of these. So if we divide by 64, we divide by 64, we divide by 64. So then this gives us y squared over, and then 16/64 reduces to 1/4, so over 4. And then 4/64 gives us 1/16, so x squared over 16 equals 1. Okay. So here, this is centered at 0, 0. And then a squared is always on your hyperbolas are always defined to be the first one, or the positive one, I should say. And then the b squared is the negative one. Oops, I'm pointing to the wrong spot. So here and here, so our a squared is 4 and our b squared is 16. So a is 2 and b is 4. So I always just remember what it's underneath. So this is underneath the y, so we're going up and down by 2. And then we're going left and right by 4. Again, the way that we determine which way it's opening, the hyperbola is opening, is based on which thing is positive. So our y squared is positive in this case. So then that means that we're going to be opening up and down. So I create my asymptotes through the edges of the box, or not the edges, the vertices of the box, or the corners. And then you go through the center as well, is what I'm trying to say. So then we're opening up towards our y's, since y is positive. So here's my vertex, and then I'm going to pull towards the asymptote, pull towards the asymptote. Here, pull towards the asymptote, pull towards the asymptote. Okay. Let's try one that's not centered at 0. Oh, I didn't find the foci. Okay. So if we find the foci here, our c squared value is going to be 4 plus 16. So c squared is 20. So then c is the square root of 20, which is 4 and 5, so 2 root 5. Okay. So if we find 2 root 5, whoops, not how I wanted to write that, 2 root 5, it gives us 4.5. So 1, 2, 3, 4.5. Oops, I went the wrong direction. 1, 2, 3, 4.5. 1, 2, 3, 4.5. So your foci are inside of your hyperbolas. Right? So I had originally gone this direction, which is not correct. So here our center is still at 0, 0. So we're going to go left and right by nothing. So our foci are located at 0. And then we're going up and down by our c value, which is 2 root 5. So plus or minus 2 root 5. Now let's try one that's not centered at 0, 0. So if we give you this one here, we're going to do the opposite of inside the parentheses, opposite of inside the parentheses, just like we've done for circles and for ellipses. So our center is located at negative 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7. Okay. Oh, positive 7. 1, 2, 3, 4, 5, 6, 7. Okay. So now that we have our center at negative 5, 7, underneath the x's, we're going the square root of 32. So the square root of 32, that's 4 and 8. It's 4 and 2, so that gives us 4 root 2. So numerically, if we do 4 root 2, that gives us 5.7. So that was under the x's, so we're going left and right by 5.7. So 1, 2, 3, 4, 5, and then almost to 6. 1, 2, 3, 4, 5, almost to 6. And then underneath our y is 16, so that's our b squared.